Hey everybody, how are you today? I hope you're having yourselves a wonderful weekend, or if it's Monday, that you did have yourself a wonderful weekend, and you're excited to start our final chapter of the school year, chapter 13. It's just like chapter 12, trigonometry, except now we're going to start solving trigonometric equations and graphing sine and cosine. Maybe not tangent. We won't. I don't think we graph tangent this year. We'll save that for next year. Anyway, to learn how to solve equations, you first need to get introduced to your good friend unit circle, and we'll learn all about unit circle. But before you can learn about unit circle, you got to learn about drawing angles, reference angles, and coterminal angles. Let's do it. First, what's a reference angle? A reference angle, this is in my own words, the shortest angle measure to the x-axis. It's probably a confusing definition at this point. I'm going to explain it while I'm working through these problems. And also, what do I mean about drawing angles? We all know how to draw angles, but these are trigonometric angles. Slightly different. Are they? Yeah, you know, angles are angles, I guess. Anyway, let's just get into this. So for part one, I'm going to be drawing the angle that they're giving me, and I also am going to do the reference angle. Note, the reference angle I'm going to do in red so that you can tell the difference between the two. Number 140 degrees. Okay, when you think 140 degree angle, I know what you're thinking. You're thinking you do this, you do that, you put in 140 degrees here, and you're done. It's actually pretty accurate. This is very much what we're going to be doing, but we're going to do it slightly different. And remember when I mentioned at the start of this lesson 2 minutes ago that you're going to get introduced to your new friend unit circle? What I'd like for you to do for this, do we need to? Now that I'm thinking about it, yeah, it would help, is put a circle here and picture the circle being 360 degrees. Now, one side of your angle will be going along the x-axis, and let's talk vocab for a second. That side is called the initial side. I frequently just call it the starting side or the starting point. Initial side is the technical jargon for it. And if you think about a 140 degree angle, that's an obtuse angle that kind of looks like this. So the second angle would be pointing here, like this. And if this is called the initial side, vocab, this side is called the terminal side. And I forgot that at the start of the problem, instead of just saying 140 degrees, it's going to be this Greek symbol, theta, T-H-E-T-A, theta equals 140 degrees. So I connect the initial side with the terminal side, and I don't need to write the 140 degrees, I just need to write the theta, because the theta that is what 140 degrees is equal to. And that is how you just go about drawing the angle. Then, the reference angle. The shortest angle measure to the x-axis. Well, here's the x-axis here, and if you did this, if you started on this initial and you went 140 degrees, you'd be here now. Is it a shorter distance to go back to the x-axis, or is it a shorter distance to go all the way back to the initial side? And the answer is you'd want to keep going forward. How far forward would you need to go? Well, if this represents 0 degrees and you traveled all the way around the circle, would put you at 360 degrees. So if you only went halfway around the circle, that'd put you at 180 degrees. And so far to get to here, we traveled 140 degrees, which means we would have another 40 degrees to travel to the x-axis. So you have the original angle, 140 degrees, then the reference angle, because you don't have to travel 40 degrees back to the x-axis, or forward to the x-axis. All right, I have a total of 5 of these examples. I'm going to move through it. I'm going to pick the pace up just a little bit. Number 2, suppose theta equals just 30 degrees. So, so I have my x-axis, my y-axis, the circle that rotates around it. My initial side is just on the x-axis, pointing to the right, and then a 30-degree angle would be roughly there. There's my terminal angle, or terminal side, and here's my theta. And then if I'm at my reference angle, if I've only traveled 30 degrees, it wouldn't make sense to keep traveling forward for the reference angle to get to the x-axis, because the shortest angle measure would just be going back to the x-axis. And if you traveled forward 30 degrees to get there, you'd be traveling backwards 30 degrees to get back. And that's the drawing the angle and the reference angle. Okay, example number 3. Let me get a fresh piece of paper. $250 degrees. Oh, theta equals 250 degrees. X-axis, y-axis, unit circle, and then we have our initial side on 0. Okay, so now 250 degrees, we're getting bigger than 180, which means that our angle is actually going to be stretching down into the 3rd or 4th quadrant. And if I remember what we were talking about a little bit ago, this would be 0 degrees, but if you went all the way around the circle, you're also at 360 degrees, which over here would be 180 degrees. Up here would be 90 degrees, and down here it would be 270 degrees. So if you start at 0 and you started traveling, you traveled 90 degrees, 180. So 250 is going to be somewhere in between 90 and 270, closer to the 270 side. And then we can draw our terminal side of the angle. So now this was my theta, this entire angle stretching into the 3rd quadrant. Now, if you were at 250 degrees and you needed to find your reference angle, is it a shorter distance to keep moving forward till we get to 360? Or is it shorter to turn around, go backwards, and head back towards the to 180 degrees? And the answer is that it would be shorter to go backwards. And how much? Well, let's see. If this was at 250 degrees, the distance from 250 degrees to 180 degrees, 250 minus 180, that's a distance of 70 degrees. So that's our reference angle. Okay, number 4. This one is going to stretch into the 4th quadrant. So, so theta, oh, I forgot to tell you what the problem was. Theta 340 degrees. Okay, so I put my first angle on the initial side, 0, and then I traveled. Oops, travel in this direction. Always travel counterclockwise. 90, 180, 270, 360, or 360 is the end, so 340 is pretty close, maybe about there. And then we draw in our terminal side. So 340 degrees, that's our theta. Then our reference angle. the shortest distance back to the x-axis. Would it be shorter to travel back to the x-axis this way, or would it be shorter to keep traveling forwards? And in this case, you'd want to travel forwards. 360 degrees concludes the circle, which means you only need to travel 20 degrees to get to the finish line, to the x-axis. What I did there, I just did 340 or 360 minus 340 to get that 20 degrees. Reference angle, always positive, never negative. Okay, number 5. What if they try to do something creepy like this? Negative 120 degrees. Negative? Well, remember that last problem where I said to always travel counterclockwise? Well, when you're going negative, you then travel clockwise. So I put my first angle here, my initial side, not angle, my first side, my initial side. And then, if you're thinking negatives, this is 0. And if I travel this direction, it would be negative 360 when I get all the way around. So down here, instead of being like when I went in this direction, that was positive 90. So if I travel in my clockwise direction, the negative direction, this becomes negative 90. So negative 120, I'd have negative 180 on the side. So negative 120 is going to be somewhere between negative 90 and negative 180. A little bit closer to the negative 90 side. And when we close this up, we have negative 120 degrees. Now, if you've traveled negative 120 degrees, if you're going to do your reference angle, is it a shorter distance to head back to 0, where that horizontal is? Or is it smarter to move forward up to the 180 point, or the negative 180 point? And in this case, it's a shorter distance to travel here towards the x-axis. And if this is negative 120, that means that you need to travel another 60 degrees to get to the x-axis. And like I mentioned before, the reference angle is always positive, no matter what. So even though this answer is negative, our reference angle still positive. All right. So that was reference angle and just drawing angles. If you have any questions, you should stop and ask those questions now, because in part 2, new vocab word, coterminal angles. Angles that have a common terminal side. We'll talk about what that definition means in a minute. Let's do it while we're talking about a problem. Find a coterminal angle such that the answer is in between 0 and 360 degrees. My first example, number 1, suppose that theta is 500 degrees. What do they mean by 500 degrees? That's not possible. Doesn't everything need to be with in between 0 and 360? No, doesn't. 500 degrees. You start here from the initial side at 0, and we start traveling clockwise. I go 90, 180, 270, 360 one time around the circle, but I still have another 140 degrees to go. So 360, that'd be 450, which means 500 would be roughly there. So this is my theta. Okay, now coterminal angles are angles that have the same common terminal side. So I went all the way around the circle once and then traveled to here, but I also could have just started here and just traveled that distance there. Now, how do you find out this measure? Well, if you know that you went an extra time around the circle, that's 360 degrees. So I'm just going to subtract 360 degrees from this, and I get 140 degrees. So this could be viewed as just being 140 degrees instead of being 500 degrees. So that's a coterminal angle because they're in the same location, that the two look the same. If I did just 140, look like that. So my two angles look the same. It's just for the 500, I ran around the block one more time. Ran the block, I ran around the circle one more time. 140 degrees. Okay, I have 4 of these examples total. Number 2, let's say that theta equals 1400 degrees. So really quickly drawing that one. You start it, well here, draw your initial side. You go once around the circle, 360, twice, 720, 3 times, 1080, 4 times, 1080 plus 360. I don't keep track of all these ones. 0, 4, 1440. Oh, so 1440. So the answer is probably like right around here. But I don't need to keep doing all these drawings. I just need to keep subtracting 360 because if this angle looks like this, I could have measured the angle here, 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 or there. I could have done a lot of different things. But you just got to keep subtracting 360. So 1400 minus 360, that is 1040. Well, that's not in between 0 and 360, so I subtract 360. Again, 360 degrees. I have to do a little cheating here. No, I don't have to. I'm just going to save a smidgen of time by using my calculator. And that gave me 680. That's still not within 0 and 360, so I subtract 360 again, and this time I got 320 degrees. That is within 0 and 360, so that's my answer. So when this angle is pointing like this at 320 degrees, it could also be, that's 320 degrees is coterminal with 680 degrees, which is coterminal with 1040 degrees, which is coterminal with 1400 degrees. All right, 2 more examples. I'm going to make them super quick. I really want to get this lesson done under 20 minutes. Number 3, what if the answer is negative? So negative 600 degrees. Theta equals negative 600. So because it's negative, meaning the graph went clockwise. It went 360 degrees, and then 450, 540. So negative 600 must be somewhere around here. And that's if you're traveling in the negative direction. So anyway, because it's negative, to unravel that and to get an answer in between 0 and 360, you're going to have to add 360 degrees. And negative 600 plus 360, that's 240, or negative 240 degrees. That's still not within our acceptable answer range. So I add 360 degrees again, and I get 120 degrees, which is pointing in the second quadrant. So the answer makes sense. So at the end of the day, negative 600 degrees, negative 240 degrees, positive 120 degrees, all coterminal. If you want to see one more example, negative 2000 degrees, well, it's negative, so you just keep adding 360. And I'm going to pick up the pace once again. Negative 2000 plus, I'm going to get you on the screen here, plus 360, negative 640, negative 1640, so add 360 again, and now it's saying answer plus 360, so I can just keep hitting enter. I didn't write down that one, but it gives me negative 1280, hit enter, negative 920, hit enter, negative 560, hit enter, negative 200, hit enter, positive 160 degrees. That's my answer. So every single one of these angles, because they're all, the terminal sides all pointing in the same direction, every single one of these answers are all, well, each one of these numbers are coterminal with each other, but the answer we're specifically looking for is 160 degrees because that is in between 0 and 360 degrees. So that is drawing angles, reference angles, and coterminal angles. And at this point, you should get started with the practice. And if you have any questions, let me know. Have yourselves a beautiful day, and I'll talk to you soon. Bye-bye.